それでは時間となりましたので始めたいと思います。アダーシュさん、イザベラさんによる Optimize Builds with Android Plugin for Gradle 3.3.0プラスです。So, okay, it's time to start the session. Optimize builds with Android plugin for Gradle 3.3.0 plus. Please give a warm welcome to Izabela and Adarsh.
Thank you very much. Thank you all for showing up today at this talk. I know there's a lot of interesting talks happening today, and we're glad that you could join us for optimizing your build using the Android Gradle plugin. My name is Adarsh Fernando. I lead the documentation team for Android Studio and DevTools documentation.
And my name is Izabela. I am a software engineer on the Android Gradle plugin team, and I work mostly around resource management.
Cool. So, okay, so why are we here? Quite frankly, long build times suck. No one wants to sit there watching paint dry when you should be doing what you all do best, which is making really cool Android apps. So just to put things into a little bit of context, let's take a pretty sizable developer team, say 50 developers. And let's say on average, each developer is doing about 20 builds a day. And if we could somehow manage to cut down build times by 30 seconds, that adds up to more than 8 hours of saved engineering time. So that team could hire another engineer whose whole job is to just focus on improving build times. So just with 30 seconds on a pretty large team, you can save quite a bit of time.
The app we're going to be using today for presenting how the optimized steps impact the build time is called Santa Tracker. It's a pretty big app. It contains nine projects or modules, almost 2,000 tasks. It's very resource heavy. It has several dependencies, so it's really good to show the impact of how optimizing your build will impact your build speed. This is the commands we used. First, we just run a clean command to make sure everything is nice and ready. And then the assemble dev debug, this is the one we're timing, and this is the times you'll be seeing here. The first baseline we run is with Android Gradle plugin 3.1. We chose this version because we saw a lot of you are still using this version or older, so we'll see the impact of the improvements. And also Gradle version 4.4. So a clean build of Santa Tracker takes 45 seconds, and incremental build after one line code change takes 16 seconds. So let's see what we can do to improve this.
Right, so we're going to first start off with a few optimizations that are really easy and you can do right on your laptop right now, and we'll see just what impact those easy optimizations will have. So the first thing we recommend is to get dynamic version numbers out of your build script. If you don't know what I'm talking about, if you look at the commented version number there, you'll see a wildcard in the version number. What that makes, so we recommend that you use a specific version number, because what that using a wildcard does is Gradle every so often will ping the repo to find out what the latest version is and download it and use it if necessary. So if you have multiple dependencies that are using dynamic version numbers, or if you have a slow connection or both, you're going to see a lot of slow builds. Another thing that is actually very troublesome with using dynamic version numbers is that versions for your dependencies can change without you knowing. So you could be building your app and you could get into a build break and you won't know whether it was your code changes or whether it was a dependency, and it's a lot harder to troubleshoot that if you don't know what's going on between builds. Filtering resources is also, it's more important for command line builds, and we'll talk about why. You can filter the resources that you deploy to an APK or to a device using the resconfigs DSL. Because large apps, you can avoid compiling all the resources for every screen density and locale if you're only really testing on one particular device configuration. And the reason it's not so important for Android Studio is because Android Studio does this for you automatically based on the device that you're connected to. So you don't really have to even worry about that when using Android Studio. So parallel execution is a Gradle feature, which is very powerful. It allows you to utilize multiple JVM threads to compile and build modules in parallel. So the way you enable it is through the Gradle.parallel property there. And then you want to play around with the actual number of threads. If you put too many threads, that can actually slow down your build. So you want to play around with that. And keep in mind, this feature is more effective the more modularized your project is, because then there's more discrete parts of your app that Gradle can simultaneously compile, the faster your whole build process will be. Converting PNGs to WebP is also something that we highly recommend. There is a feature built into the plugin called PNG crunching, which is a resource-heavy task, so that will make build times longer. We disable it for debug because we don't really care about APK size when you're just trying to work on the logic of your app. But we recommend converting to WebP because you automatically get 25% reduced file size without any build time compression. You still get transparency on API level 18 and higher. One thing to keep in mind, though, is because it is a highly compressed file format, you will see slightly higher CPU usage during runtime. But when you do decide to convert your PNGs to WebP, Android Studio makes it super easy. You can batch convert. You just right-click on the directory and select the action convert to WebP, as you can see here. Android Studio actually shows you the before and after and a diff. And I don't know about you, but I can't really tell the difference too much between the images, but I can tell the difference between the sizes. The WebP version is only 16% that of the PNG. And for that module in particular, we save about 13.4 megabytes. So quite substantial, just for one module out of the 9. Cacheable tasks is another Gradle feature that you want to enable. So what cacheable tasks is, Gradle allows you to annotate the inputs and the outputs for each task. And that way, if the input for a task doesn't change, Gradle can assume the output for that task won't change. So it just skips rerunning that task altogether. So when you enable this to true, you get to benefit from that. But also, keeping your Android Gradle plugin up to date is super important because with each new version, the team is making more and more tasks cacheable. So the more you keep your plugin up to date, the more this becomes worth it. So the last really easy optimization that we're going to talk about is disabling multi-APKs. If you're publishing to only Google Play Store, you really don't need it. When you're debugging, using Android Studio, like we mentioned, automatically only uses the code and resources for the device you're connected to. So you really splits. So what about publishing? When you're publishing, you absolutely should be using Android app bundles, and I'll tell you why. So Android app bundles is an official publishing format. This is what it looks like. It's basically a zip file with a AB extension. And what you'll notice is it really does resemble your local project structure. All it's doing is compiling your code and resources, keeping the project structure, but deferring actually packaging and signing APKs to the Google Play Store. So it's one publishing artifact for all APK outputs. So how does that work? How does that happen? That's through something called dynamic delivery. So dynamic delivery is when Google Play Store will compile, will package your app, all the common code and resources into a base APK, and then all the code and resources that are specific to a device configuration, like an ABI or screen density, it will package those into discrete split APKs. So if we look at this animation here, before, if you're not using multi APKs, all the code and resources for all the different device configurations would be packed into a single APK, and your users will have to download all that information, even though they're not using most of it. But with dynamic delivery, they only download the pieces they need. So for you, it's a single upload artifact. It's just one zip. And for users, it's a far lower download size. So is it hard to build an app bundle? Absolutely not. I'd say 99.99% of users can build one today if they're using the latest version of Android Studio. You just click build app, just build bundle instead of APK. And if you're building from the command line, you can just use the bundle task as shown. We still recommend you build APKs for debugging because it's faster to build a single APK than it is to build a bundle, but it's a lot easier to publish one bundle instead of numerous amounts of APKs. And finally, when you do upload your bundle to Play Console, it provides a lot of rich information to show you just how and where you're saving a lot of your upload size. So just to recap some of the basic optimizations we've covered, we told you to filter those resources, enable parallel execution, convert your PNGs to WebP, and enable cacheable tasks, and also completely disable multi-APKs. We don't need them anymore. So with that, with our unoptimized build, we had 45-second clean build and 16-second incremental. With just those basic optimizations, we were able to bring it down to 15 seconds for clean build, 7 seconds for incremental. So already we're seeing that 30-second build speed improvement just from those few steps. But those are things that you do to for your project to make it faster, but how about some of the things the plugin does for you?
Thank you. Right, so one thing I like to tell people, one optimization you can do, it's very easy. You can just upgrade your Gradle plugin to the latest version. And I would like to talk about the things that we're working on that contribute to this being faster. First, let's talk about light R classes. This improvement is about the new handling of R classes in the build system and in the IDE. Previously, what would happen, APT would generate the r.txt file, then we would create the r.java source code, and only then call javac to create the bytecode. Now we skip the source code altogether and generate the bytecode directly. This can lead up to double-digit % speed improvements for big library projects, especially multi-module ones, due to the R classes being really big, especially the higher you get with the dependency tree. Also, skipping the source has a great impact on the IDE itself for sync and indexing, because there's a lot of less code to parse. It doesn't parse the source code anymore, it just parses the r.txt file. So you can see the faster build speed, faster sync, and faster indexing. Second, lazy task configuration. Gradle has created this new lazy task configuration or lazy task API, which allows us to avoid initializing and configuring unnecessary tasks. By unnecessary, I mean a task that is not needed, that task that produces an output that is not consumed in this build. A good example is the help task. So if you run the Gradle wrapper help, you can notice that it takes quite a long time despite just outputting the help menu. This is because it was trying to run configuration on the whole universe. Now it will only configure what it really needs to, and it will be much faster. It will skip the unnecessary configuration. So configuration on its own is quite fast, but when you have multiple variants, it adds up. So it's better just to skip it altogether. So we've been working on implementing this API on our side, but if you have any custom tasks, you can switch to it as well. So if your custom tasks probably look something like this, using task of foo and using the create method, and everything in this create block will always be executed regardless whether the task is run or not. So what you can do, you can migrate to the lazy API. Instead of using task, you can use task provider. Instead of create, use the register method. Now everything in this block will only be executed when a task actually needs to run. Another thing, incremental annotation processing. Google, Gradle, and the open source community are working together to make annotation processors more incremental. Some of them, like Dagger and AutoValue, are already finished, so feel free to update to the newest versions. Butterknife is also in process, so you can track the progress on its GitHub page. On our side, we're working on making data binding an isolated annotation processor because it impacts a lot of builds, and also to make it incremental and isolated. We want to make it clear to everyone what impact each annotation processor has on the tasks or on the build time. And so we want to make them faster and report them better to you. One new thing in the newest version is improved application packaging. We did a lot of optimizations, especially around APK signing validation. So you can see build improvements around double digits sometimes for like very big, heavy APKs, both in full and incremental modes, just by upgrading the plugin to the newest version. And now, back to Adarsh.
So on previous versions of the plugin, you might have seen this error. It occurs when you have a dependency that is using different versions across your compile and runtime class paths. So in here we have appcompat v7. On compile, it's using a lower version number than the same dependency on your runtime class path. So previously, you might have had to do something like this, where you actually specify the version you want to use by changing the resolution strategy for the compile time class path. But Gradle doesn't even recommend that you use this API, and now with the latest version of the Gradle plugin, you don't need to. It does it for you. What Gradle does is when it configures, it figures out what the dependency version numbers are being used on the runtime class path, and it uses those version numbers to upgrade those dependencies on other class paths, such as the compile and also your test class paths. However, one thing the Gradle plugin does not do is it won't downgrade those dependency version numbers on the other class paths. So you might get into this situation where you add a dependency to your app, and then a library that it's using has a runtime only dependency that it's using a higher version number. So it won't actually downgrade your compile, your compile time class path to match your runtime. One thing that you'll do is just update the dependency that you add to your app, and if you have multiple modules using the same dependency, definitely use project-wide properties to kind of keep them all in sync. Another area that the team has worked a lot on is project sync. You might be wondering, what is project sync? Why do I have to do that every time I even put white space in my build script? Well, there's actually, project sync is super important for Android Studio. It provides the backbone and understanding of how your project actually is structured to Android Studio. How many modules you have, what are the dependencies between those modules, what product flavors and build types you have, all that information is given to Android Studio at Project Sync. So you can see there's a lot happening right here. Build action is fired up to gather that information from Gradle and the Android plugin. That information is fed back into Android Studio, and Android Studio saves that information to disk. The reason it saves it to disk is so that the next time you start up your project and you haven't really made any changes to your project structure, it doesn't have to sync everything all over again. So what are we doing to improve that? Well, when you think about it, when you have variants and you have to do a sync on each one of those variants, the more project variants you have, linearly increases the sync time. However, you're most likely only working on one variant at any given time. So although the initial sync is still a full sync to figure out all the variants that you have and how your project is structured between those variants, any other changes that you make only syncs up information for that variant, and you'll start seeing a lot faster sync times, up to 3 times faster, in fact. D8, R8 is something we've invested a lot in, and you might have heard about it, and I'm here to demystify that a little bit. So what is D8? So as of 3.2, D8 was a default part of the toolchain, and that's our DEX replacement tool. So it actually replaces the old DEX tool, but it also integrates desugaring in the same step. Desugaring, if you don't know, is using where it rewrites your Java 8 language features uh, so that it's backwards compatible and can run on the Android platform. R8, in fact, isn't a separate tool. It's just repackaging D8, but adding a replacement. So let's take a look at what that actually looks like. So this is before 3.2. Java C would first run to create your classes or to compile your classes. Then desugar would run on those classes to rewrite your Java 8 language features. And then ProGuard would kick in to shrink, obfuscate, and optimize. And then finally, D8 would run to compile your classes to DEX files that can run on the Android platform. So in 3.2, we combine those D8 and desugar. So it's one single step for both. Simplifies things, but there's one little problem with this. You'll notice that ProGuard doesn't actually see your final class files before they're compiled into DEX. So it actually doesn't get a chance to optimize, shrink, and obfuscate the final class files. So what did we do? We combined that step into the D8 desugar and called it R8. So now your desugaring, your obfuscating, your shrinking, and optimizing, and dexing all happens in a single step, and it's just a much cleaner toolchain. So compared to ProGuard, we're seeing very significant build time improvements, and even slightly more faster improvements for when you're using a more aggressive version mode called full. So R8 is currently experimental. It will go default in 3.4, so we highly recommend that you enable it and try it now. The way you do that is just in your Gradle.properties file, you just add this flag. And also, if you want to experiment with full mode, which is the more aggressive version, because R8 is designed specifically for Android, it can make certain assumptions about your project and optimize your project a little better than ProGuard could. So try that out. Definitely give the team feedback if you're seeing some weirdness or anything that you don't expect, but definitely give that a shot. So on the latest plugin, we haven't done anything other than upgrade the plugin version from 3.1 to the latest version of 3.5 and Gradle 5.1.1. So where we left off was we had a clean build of 15 seconds, which is pretty good, and an incremental build of 7 seconds. But just by upgrading, we could bring that down even further to 10-second clean build time. Thank you. Thank you. Yes. And 3-second incremental build time. So super fast. So where do we go from here?
Thank you. So now we know we've optimized our build speed, we're on the newest plugin, but somehow, what if your build still looks suspicious? It still takes longer than you thought it would. So let's see how we can identify these bottlenecks. And this is something the team does when we debugging things. Gradle comes with two profiling tools. They're the scan and profile methods. You can just use them out of the box, just normally as you run with your Gradle wrapper. Let's see the first one. Scan, you just add --scan to how you normally execute your build. What this will do, it will warm up the daemon a little bit, then run the build, analyze it, and send the data to the Gradle servers. Then we'll share the URL with you, and then you can see that in your web browser. So one thing to keep in mind, again, this sends data to Gradle servers. So if you're working on something confidential, I will tell you what to do otherwise. This is how an example build scan looks. You can see the tasks that were run, whether they were up to date or if they were executed, how long they took, and all other different information there on the left as well. For example, what we could use this for is if we had the check manifest task, and if it was actually not up to date, that would be telling us, hey, you have a task or a plugin that's actually modifying the inputs for this task. You should have a look at that, see what's going on there. Right, so if you don't want to share information with Gradle, you can use -- profile. It will be slightly less extensive, but all the data stays locally on your computer. It will still generate an HTML report, but will just be there in your, on your computer. So this is how it looks, the example profile report. It still has all the necessary information. It still has the total build time, which tasks run, the dependency resolution and the execution, everything is still there. You can just click through it. If you want to get the information about why a certain task run, you can also run with -- info, and this will in detail tell you this task run because this input in particular was changed. So as you've noticed, we've been kind of running these by hand. What we can do is use a thing called Gradle Profiler. It's a project done by Gradle. It's open source. It's available on GitHub, so you can see their source code. You can check it out locally, build it, and use it. This is the repository you can grab it from. Using it is very simple. You just use Gradle Profiler, specify that you want to do a benchmark, give it the project repository, your project's directory, the task as you normally would use them with the Gradle wrapper, and then tell it how many warm-ups you want to do. You want to do 5 or 10. And then after this, it will actually run a few benchmarks, collect all the times, calculate the average, the median, and the standard deviation. So it gives you a little bit like nicer and steadier numbers than running it by hand. What more? You can specify different scenarios. So you can just do clean builds, which is fine. But the interesting bit is the incremental builds. And what it will do, if we specify an incremental build scenario, we can say run assemble, but after doing an ABI change to my Java class. It will do this automatically. It will affect this class only. And this doesn't affect the build time on its own. So it will not affect the calculated averages and so forth. It will be done automatically before every single build and then cleaned up afterwards. Another interesting thing you can do, you can compare different build systems. It works with Buck, Bazel, or Basel. So Buck, Bazel, Maven, and of course Gradle. Here is an example how to do it with Bazel. You specify still run the assemble task on this Bazel target, and you can just execute it by running -- Bazel and passing this scenario name to it. This will give you a nice comparison between running it with Gradle or with a different build system. One more thing that the team is working on currently together with Gradle is a thing we call attribution. So this is our way of answering the question, why is my build so slow? We're working on giving you the nice information of attribution of each annotation processor, the full compile time, also the attribution of tasks to all the plugins that you might be using, and also giving more information about which tasks run and why. This will be integrated both in the Android Studio and in the Gradle plugin on its own, so you can get this information regardless whether you're running it in the IDE or running it from the command line. Again, this is something we're working on currently, so please keep an eye on the release notes and keep your Android Gradle plugin up to date. So yeah, thank you all for coming.